All right, good afternoon. We've got our fabulous 5 students. All right, well, this is the end of week 9, so coming down to wrapping up CSE223 next week. Any questions? PA5, networking, sockets, threads, any of the stuff we've gone over that people want to talk about, this is a great time to do it. We're going to start something new after this. But let's talk questions first.
Can we talk about reflection, potentially?
Tell me about reflection.
So, basically, let's say I needed to call a function, but I needed to do it from a string. There could be some metadata on a method or a function that says, this is the name of the function, and you can call that function from the metadata tag.
Mm-hmm.
So, I think override in this language, when you see the little override tag, that's also considered metadata, and some of these remote procedure call systems, basically, you pass in a string name of a function, and it's just going to go through the metadata with reflection and find that that method you're looking to call with reflection.
Interesting. Okay, so this is not something I'm familiar with, but it does sound like interesting feature. But yeah, it's not something I understand well enough to talk on.
Okay.
Okay, yeah, this does sound cool. A lot of languages have this ability to introspect, to take a string, for example, and execute it as if it were code, which sounds like it could be related to this. And that's an aspect of programming languages that I think is fascinating, and it's the thing that makes computers work at the machine language level. And languages like Lisp, for example, that expose that at a higher level, let you get into some interesting program design.
Well, yeah. The reason I was wondering is when I built my PA5, I basically built it with a network manager, and it's got a few methods on it, like sync start games, sync names, sync board size, a couple of things I want to be synced.
Mm-hmm.
Every time I add in one of those functions, I can't just like send a string name of the function over the wire and expect that it will call it. I have to go into that thread and manually say, hey, if the message was this string, go ahead and call this function.
Mm-hmm.
And with reflection and some of the ways,
Right.
procedure calls and game engines do it, that you just pass in a function name and the arguments in stringified form and whatnot.
Right. Yeah, so I know Java has this capability. I have not used it. And the workaround is straightforward, but not terribly fun to do, right? So like you said, just have a parameterized function list, and based on the parameter, call the appropriate function, and possibly convert arguments and so on and so forth. Yeah, it's interesting.
Maybe you could.
Yeah, I didn't think about that. You could have used special signatures for each message received, right? And called a different function.
Mm-hmm.
One other thing I would wonder is if you could like stringify a delegate and then parse that and call it.
Mm-hmm. Yeah, that might work. I have a system I've been working with that compiles C code on the fly. So you send a message from one cell to another, and that cell actually runs a GCC on the message, and then starts executing the compiled code. And that's a fun system to mess with. You can get into all kinds of interesting difficulties with it.
Sounds fun and dangerous.
Yeah, don't even think about security.
That sounds really cool.
Yeah, it's a fun little project. It's the one that usually overheats my CPUs when I fire it up.
What do you send again? Like the name of a file, and then it GCCs it and runs it, or?
I'm sending in bare code,
Oh.
and
wow.
it's all Java based. So it takes the code, it saves it in a string, and then it throws it into a file and calls GCC, and then it goes ahead and executes that.
I have to
That sounds
wonder.
fun.
I have to wonder if that's how platform executes work in certain languages. So,
Hmm.
like in C#, you can call native code,
Mm-hmm.
and like let's say I wanted to call a native function, I could do a platform invoke. But I always wonder if that's just like setting up a little micro C program and transplanting that function into that little program and just running it.
Yeah, I mean, not compiling on the fly probably, but yeah, if you send binary code for an executable, whether it's a JVM or a native program in a different language, all you really have to do is make a call to the right location in memory, and start executing that code. Passing information back and forth can be tricky, but
Marshalling is hard.
yeah.
Marshalling is always a pain.
Yeah, this is why like making your own language can be such a fun exercise, because you can sort of do all this stuff, and if you're not planning to distribute it to the world, you can make life a lot easier on yourself, right? If you're just trying to do something for yourself, you can dream up your own language and your own hooks and your own just-in-time execution of other languages and so on and so forth.
Now,
So you'd have to make up your own compiler on everything, right? I mean,
Sure, yeah.
not so much anymore. Not with LLVM. Like Rust and Go and all these new languages are being spun up out of a back-end compiler called LLVM, and you just have to make the front-end compiler, so then you have native code.
Yeah, and there's lots of tools to do that. There's Lex and Yak. Yak is yet another compiler, and that's been around for decades.
what does it do? Does it just it takes your rules, compiles it into something?
It builds a compiler for you, basically.
Yeah.
So it's a compiler, yeah.
It's kind of like,
Oh, okay, I get it. Compiler.
Yeah.
yeah.
That's interesting.
But
And then you can just work on your middle end.
yeah, exactly.
All that stuff for you.
But I highly recommend writing your own compiler at least once, just for kicks. And if you keep your language fairly simple, it's not as daunting as it might sound. Writing a good compiler is daunting, but
Most languages are C-based, right? Or like if-else, all that kind of stuff. Like that's pretty common in most languages, right?
that's pretty common in a lot of languages. Most languages we use now, yeah, they look very C-like. But there's other languages like APL, which is a programming language, which looks nothing like other languages. There's no ifs, and things like that. It's all symbolic. There's Lisp, which is its own thing. There's COBOL, which you could write complete sentences in. There's Snowball, which is another symbolic language. It's for string processing. And there's all these kind of sort of bizarre languages. There's Markov algorithms, and then there's the kind of reductionist languages like BF, which is like 8 symbols, and you write your code out of that, or Rockstar, which is like a great language. That basically your programs look like 70s song lyrics. And these are all, you know, Turing complete languages. Anything you can write in Java, you can write in Rockstar. It's just more fun in Rockstar.
There's a website that holds all of these. I think they're called what do they call again? Like
Esoteric languages.
esoteric.
Yeah.
Languages, yeah.
Yeah, if you like that.
Mm-hmm. And again, as I've said before, you know, part of learning programming is, you know, learning different languages, but a bigger part is learning how to learn different languages, right? I think human languages are the same way. After you've learned, you know, half a dozen languages, you get a new language. It doesn't take you as long to pick it up, right? Even if it's slightly bizarre, or maybe very bizarre compared to what the languages you know. You've got those mappings in your brain for how to work with it, even if it has a different look and feel. All right, cool. Well, any PA5 questions?
Kind of easy question. What's the default? Oh my god, why am I drawing a blank on? One moment. 2 seconds.
Okay.
The number of the backlog for server socket.
I think it's 50.
50. Okay.
Yeah, and that's fine. We're not actually writing a server in the sense of when you're done with the game, somebody else can connect. We're really just doing server runs, one client connects, you play, you're done, socket go away. So we don't even need a backlog.
Yeah, it just requires one.
Yeah, and the default will be 50, I think.
Okay, awesome. Thank you.
You're welcome. You could extend, you know, the definition of the client server setup here a lot of ways. Don't do this for the version I'm grading, but you know, you could require a password in an insecure way, or you could, you know, decide whether or not you're going to play with the person who connected to you and choose to reject their connection, you know, and things like that. Sockets are so much nicer in Java compared to
C#.
Yeah, and definitely compared to C.
It's probably nicer than that too, but you have to do quite a lot of exception handling in C# for sockets.
That makes sense.
That's why I made like a simplified connection class, which is a wrapper around it.
Okay. Yeah, and in C you have to, you know, you're basically manipulating these data structures at a low level, so you construct a socket, you know, with malloc, or you create one and use its address, and then you have to set up the individual fields in there based on what type of connection you want, and the IP address you're connecting to, or, you know, if you're accepting connections, what your port number is. And it's not a lot of code, but it's a lot of detail in a little bit of code, and getting that just right is challenging. And Java, it is pretty painless once you know, once you've seen one or two examples. It's kind of the same thing over and over.
Since WebAssembly is a thing, I wonder if there's ever going to be like a Node.js or Angular implementation of like the C programming language, like C web coding.
Interesting. Yeah, I don't have a lot of experience with things like JavaScript, but my impression is they're not that dissimilar from C. I mean, C is really assembly language at a slightly higher level, right? You don't have direct if statements in most assembly languages, so you add if statements and you add looping, but it's really, you know, high level-ish way to write assembly language code, which I think is why, you know, a lot of other languages sort of have similar structure. And yeah, the I/O is interesting too. And we really haven't talked much about Java I/O. We've stuck with, you know, two classes: print writer for output, scanner for input, and that's a really narrow, you know, selection of a much broader topic where there's buffered and unbuffered ways. There's cooked and raw ways to do I/O and so on. And if you wanted to do, you know, communication over a network, it would probably be something you do, you know, with low-level I/O, rather than just print writers or scanners. We happen to have a message protocol for PA5 where we just need, you know, a plain text line and it's human readable, and so that's going to work fine. But, you know, if you wanted to send, you know, millions of bytes of information over, you wouldn't send it as ASCII characters. You wouldn't send X coordinate as a 3 or 4 digit number, right? You would send it out in binary. And for binary I/O, we get into, you know, different kinds of classes, and so there's a whole hierarchy of how these things are built up. So like input streams are slightly lower level, right? But we're just using them to construct a scanner. I don't have a good reference site here. All right. So reminder on SLP presentation. So thank you everybody who turned in your SLP report. About a third of the class overall across both sections did not turn in their SLP report. So, but hopefully, if you did not turn it in, you've at least contacted me to let me know what your topic is. And I sent out emails to everybody who was missing an SLP, and heard back from some of you. So thank you for that. So reminder: the presentation is a week from today. It's at 3 o'clock. It's in Zoom. The link is on Canvas. And this will be just like we did in 222. Show up to Zoom.
It's
maybe
a week from today?
Yeah.
Oh, I thought it was Tuesday.
Oh yeah. It's sorry. I thought today was Tuesday. It's a week from Tuesday.
Okay.
Yeah. Well, normally I'm rushing the week, and this time I'm lagging it.
We can't miss a Tuesday class.
Yeah. Let me get an exact date instead of this and next. So SLP presentation June 7th, 3 to 5 p.m. So same setup as in 222. Hop in a couple of minutes early. Join the Zoom session. There'll be usually Izad or I will be sharing our screen. There'll be a list of projects and names and what room you're in, and you'll be in a room with, you know, 2 or 3 other people typically, and go in that room and just take turns doing your presentation. If there's nobody in the room except yourselves, you'll be presenting to each other. But throughout the 2 hours, people will, you know, come by the main Zoom room, look at the list of topics, and say, "Hey, I want to know about, you know, this solar-powered dog feeder." And so they'll hop into the room and they'll listen to whoever's talking. And they may hop in and leave. They may hop in and stay and listen. They may ask questions and so on and so forth. So it's just an online version of what's sometimes called a dog and pony show, right, where you basically talk about your stuff and take questions and so on and so forth. All right, and if I have not heard from you, I sent an email asking for information by Wednesday night, that was last night, as to what your topic is so that you can be added to the list of presenters. If I did not get that, I put a 0 in for the presentation, but that's to catch your attention. So send me the name of your SLP and tell me that you're going to present. I'll take out that 0, right? You can show up Tuesday, present, get 50 points. That's half of your SLP score, and the SLP is 10% of your grade. So no matter how much or how little you've done on the SLP, right, you can still come to the presentation and talk about it. And 5 minutes talking about your project is fine. And if you thought you were going to do this and then you scaled it back to do this and you ended up doing this over here instead, you can talk about that, right? It's great if you decided you're going to build something and you built it and it worked great and everything's done. But the goal of this project is education, right? Learning, figuring out not just the technical parts, the engineering parts of a project, but the management parts, the scheduling, the managing deadlines, setting expectations, and so on. And so if it doesn't feel like you succeeded in your SLP, it probably means you succeeded in those parts of your SLP, lessons learned, so on and so forth. So, and you'll be doing this, kind of thing at university. You'll have a capstone your last year, which will be much more formal and have, sometimes weekly reviews with a sponsor and so on and so forth. So this is kind of a low-key way to kind of preview those experiences and get some practice with them. So definitely take advantage of it, and it's worth 5 points out of your final course grade. So it's worth the effort.
Yeah, I think it's a bit less intimidating over Zoom too.
Definitely, because you can dress comfortably and you can slouch if you want, or drink a ginger brew, or whatever.
As long as you talk professional.
As long as you talk professionally, yeah. But it is kind of cool when it's in person, because it's usually like the whole side of the STEM building gets taken over, and it's just lots of people and tables with projects and cool contraptions and slideshows and stuff like that. And that's just a fun vibe, right? People walk in the door and see this and come over and start looking at things, and the dean will stop by, or sometimes the college president swings by, stuff like that. So it's pretty fun. And yeah, good comment. You don't have to abandon your SLP after Tuesday, right? So our goal is that you find something you really want to work on. You really want to make a home automation system without doing Alexa, and so maybe you're working on that. You can continue to work on this on your own, and sometimes you can leverage this into projects for other classes down the road. It can be a starting point. So the quit button for PA5, my main requirement is that when either player hits quit, their window goes away and the other person is told, hey, this person has quit. Now, whether that other player, their window just suddenly disappears, or they get a message saying the player has quit, I'm fine with either of those. And some people decided, just closing the window would be too abrupt, so they put a message up saying, other player has quit. So either way is fine. But what I want is if one person quits, the other person doesn't keep clicking the mouse and nothing's happening, and they have no idea why, right? So I want them to get an indication that the other player has left the game. And then if they have to close out the window, that's fine.
Is it okay if it just kind of locks the window and shows like who won the game, or like tie game or whatever?
Yeah, long as there's an indication to them that the game's over because the other person quit. I don't care if you lock it, or if they can keep playing mindlessly, or if the window disappears, or if you crash their machine or whatever. So no, don't crash their machine.
If you or the client hit click, that window, whoever hit click has to go away? Or can it just stop and lock up too?
I if I think it makes sense to close the window, but if not, at least print up a message saying you've quit the game,
Okay.
right? So you don't want anything mysterious going on, basically. So if someone accidentally hits the quit button and they don't know it, they shouldn't just think the game is broken because it's not listening to my mouse clicks anymore.
Okay. And you want that printed on the frame, not on, like, not like a print message in the command line or anything.
Yeah, let's print it on the GUI somehow. Either change the title bar or do a pop-up window, or something like that.
Okay.
But as someone just said, if you call system.exit, that will shut down the whole shebang, and that should stop your thread as well.
Okay.
And then in your thread, if you come out of the while loop, your thread usually has a while loop saying, while there's more input coming from the socket, do such and such. So that loop will exit if the other side's closed the connection, and so you can just put a system exit outside that while loop, and that should make the other player's window just disappear as soon as the connection is closed. But that's not required.
I feel like there was another question I had, but I'll try to remember it now.
Okay, yeah, we can loop back as we go forward. All right, well, let's talk about the URL class, and this is a fun class to play with. So URL is a universal resource locator, right? This is basically a way that we can access typically web pages from somewhere on the web, and many people probably are familiar with how the web works. But let's do a quick once over on some basics anyway. So web pages, right? They're just documents that we can download from a machine. We've talked about client-server setups. My browser is a client, and I can request a page of information from a server. And you can put an address in here. So I'm going to do apod.nasa.gov, and this resolves to an IP address. I might have this address wrong. This resolves to an IP address, and my client will go to that IP address and look for a server socket on probably port 8080. And if it finds it, it will, make a connection. A pair of sockets get created and connected to each other, and my browser probably asked for index.html. And that's the name of a file on the server. And the server sends the contents of that file over, and my client, my browser, uses that to display a page. So if you don't know about Astronomy Picture of the Day, check it out. It's a fun website. They have different picture each day, and they're usually pictures from the Space Telescope or maybe from some event that just occurred. Cool pictures of eclipses, things like that. And it's a nice set of images, and it's pretty humbling sometimes to look at this stuff. So I mean, this is what can you say about it? And they're nice high resolution images, and a lot of these come from Space Telescope, and Space Telescope version 2 is up there now, so that's good. And they'll tell you a little bit about it, and so on and so forth. And so each day they have a different picture up. And I like to pick on this website because it's a fairly easy website to interact with. Now, in your browser, you can hit something like Control U and open up a new page that shows you what that web page actually looks like, the actual, characters that are sent to you when you request a page. And this is the contents of that web page. And this is HTML. So HTML is a markup language, right? Hypertext markup language, and it's a series of tags and some plain text. So astronomy picture of the day is surrounded by this tag title, which is why I've got an astronomy picture of the day up there. And then H1 says I want to print the following text in the style of header 1, which makes it a certain font size and bold-faced and so on, and centered, and so that's where that's coming from. If this said H2 astronomy picture, it would look different. And tags are ended with a matching tag with a slash in front of it. This is a very old protocol, decades old, but it still works, right? And it's a way to take information and convey how you want it displayed without adding a lot of extra detail, and it's a way that's entirely portable. So if I take all of this and I just throw it in a file and I type in the name of that file in a web browser, right, I will see all of this. So our first question is, how can we access this information from a server so that we could, do something, scrape a website for information, or, make our own web browser or something like that. And part of this are these hyperlinks. So the A tag says, hey, I want a link to this address, and I want the link to look like Robert Nemiroff. Right? And so down here, you'll see an entry that says Robert Nemiroff. Right? And it will resolve to that URL on the bottom left. Right? Why does it go to that URL? Because that's what's inside the anchor tag associated with that string. So this is, nothing new. If you've looked at this before, this is all a rehash, but if you haven't, that's really all that's going on with web pages. Now there's a lot of layers on top of that when you start getting into content generation and JavaScript and style sheets and all of that stuff. But at the lowest level, a web page is just a bunch of marked up text. And a web browser is just something that can request a page and then interpret that marking to render a page in a particular format. So we're going to pick on this page, and we're going to do this from Java. So I'm going to do this from Eclipse because there's lots of try-catch blocks and there's lots of imports we have to do, and Thursday's a good day to be a little lazy. So let's make a new package, a new project, and we'll call it web page stuff. Alright, this is going to be GUI based, so I'm going to make this all a J-frame. And I'll just call this main window. Alright, so we're up and running. We've got a basic J-frame. We can do stuff. We can close it. And what I want to do is I want to use this URL class to open a connection to a web server and request a page, and then pull down the information from that page and see what we can do with that. Alright, I think I'm caught up on comments. Alright, so I'm going to add a button to my window here. So I'm going to do an absolute layout still. And I'm just going to put a button over here. And I'm going to call this button Go. And I'm going to do this so that we can run our program. We can get the JFrame up there, and then after that's up and running, we'll hit the go button, and that will actually create the URL object and try to access the server and pull the page down and stuff. So let me double click that to get to some code, and let's write some URL code. So we're going to open a connection to APOD, that's the astronomy picture of the day, and we're going to read the HTML from there. So I'm going to make a URL object called page, and I'm going to make a scanner object called SC, because I don't have any imagination. And I'm going to say page equals new URL, and I'm just going to put in an HTTP request. So I'm going to say HTTPS ://apod.nasa.gov. So this HTTP, that's a protocol. That's the hypertext transfer protocol. We could say FTP : we could say mail to : file : so this is the one we're concerned with, and this requests hypertext. So marked up language, and the S is the secure version, so we don't just send plain text information back and forth anymore. We use a secure connection layered on top of, you know, some kind of encryption mechanism. So we'll construct a page, and let's just try that. So I need to import these. So I'll import URL, I'll import scanner. And then this is going to have to go in a try-catch block. So if you haven't discovered this already, right, if you hover over an error like this and it says, hey, one quick fix available, surround with try-catch, well, I can just click on that, and it will add the missing code for me. So it puts in a try statement, puts my statement there, it does a catch for the right type of exception, prints out an error message. And I'm just going to change this error message. It will just look like that. Alright, so if I run this, I get my window, I hit the go button, and, you know, nothing seems to happen. So that's okay. But if I put in a bad address and I try to run this and I hit the go button, oh, that's not what I expected. Oh, I'm not generating an error. Okay, that's fine. We got to take it one step further. Alright, so we're not going to notice an error until we try to actually pull text from this page. So we've got the URL, we're constructing it, we're getting back a URL object. We want to read information from that, that server. We're going to use a scanner, we're going to construct the scanner using this OpenStream. So OpenStream opens a connection to the URL, that's what actually reaches out and says, I want to pull information from you, and OpenStream returns an input stream. And remember, input stream we can use to construct a socket. So let me add one more tag in here. So we'll do a new scanner on page.openstream. And this has got to get thrown inside a try-catch block also, so I'm just going to change this to an exception. Alright, so now if I run this and I hit the button, everything looks fine. If I have an address that's not valid, right, then I'll get an exception saying error opening page, unknown host exception. So there's no such server available as pod.nasa.gov. All right, well, if we come out of the try block successfully, presumably we've opened a connection, and we have this scanner object, SC, that we can use to pull information from the server. So let's read the page.
Coincidentally, there are lots of libraries that can do this for you, like AstroPhi.
Oh yeah, yeah. So we'll go into our usual while loop. Well, we have another line. Let's read that next line, put it into string, and then let's print that out. And then when we're done, we can just close our scanner and we'll be done. So without peeking at the error message by hovering, what's wrong with SC here? What's the error message going to be if I hover over that? It's a kind of subtle one. This is something that happens when you automatically add try-catch blocks sometimes instead of typing them in.
Isn't it going to ask you to do a try-catch?
No, it's not.
It's not initialized.
It's not initialized. So really after I get this error, I should just return. If I don't return and I continue, it's possible that SC has not been initialized because, you know, maybe an error was thrown up here. So that's what it's complaining about. So if you're not really paying attention, right, your quick fix might be just to set SC equal to null up here. That's not the right fix. That will get rid of that error, but your goal is not to get rid of the error. Your goal is to get rid of the bug, right? And those are sometimes different things. So in this case, you know, the bug is that if I can't open the page, I'm continuing to try to read from, you know, this non-existent scanner. So the right thing to do is just return here, and that makes that error go away. All right, let's go ahead and run this, and let's hit the go button, and bingo, we've got a bunch of HTML coming in from the server. And this HTML should look familiar. It's the HTML that we saw when we looked at the source code for this page. Right? And that's really all that my browser is doing. It's not written in Java, as far as I know, but the effect is, you know, it's making a connection to that server. It's sending it the name of the page that we're after, which is typically index.html, and it's getting back a bunch of information. The only thing different that's happening in my browser is then it's using that to create a nice, carefully laid out page that, you know, has different fonts and clickable links and so on and so forth. But the main thing going under the hood is it's getting all this information from the server. Well, that's what we just did in Java. And it's really, you know, 2 lines of code here, and then our standard scanner while loop. All right, so that's a promising start. Questions up to here? All right, so the next question would be, how can we interpret this HTML to display something more meaningful than all of this business? Because the information we want is in here, right? but it's not very easy to read. Now, if you're scraping websites, if you're just trying to pull information down and do something with it, right? This may be exactly what you want to do. You may want to look for a particular string of text somewhere in here, and you know that when you find that string of text, you want to find the next thing that starts with angle bracket A href, and you want to pull off this address, right, or whatever. So if you want to get weather information from a site and you don't want to use a pre-existing app, you could make something like this. You just have to know where in this HTML blob is the information that you actually want. And so a couple of years ago in fall quarter 224, the elections were going on. The elections ran a few days after polls closed, and they were still counting ballots. And so, partially as an example for 224, right, I put together a bash script that would go out to an election results website and scrape information for Pennsylvania and figure out what the current counts were, and then keep a history of that. And it would use a text to speech synthesizer to announce changes in the current standing of the election, so on and so forth. And this is easy to do if you have access to the raw contents of a web page. So even just something as simple as this can be really useful, and doesn't take you long to put together, and you have the whole power of a language like Java to do whatever processing you want on this. And one thing we haven't talked about in Java is regular expressions, but there's a regular expression class, and you can define a regular expression like in 224 and compile it, and then run a string against it and see if a string matches a certain pattern, and optionally take pieces of that matching pattern and throw them into other strings that you can access later, and so on. So lots of things you can do around these lines in Java. All right, but we want to display something. We want something like this, right? We just want some eye candy. So there's another object, another class that we're going to work with, which is a JEditorPane. And so let's go back to our design window, and let's find JEditorPane. And this one hides on me, JEditorPane. And I'm going to drop this in here. I'm going to make it a little bigger. I'm going to try to make it a little bigger. All right, and we're going to use one method from here. So JEditorPane, we can component to edit various types of content, and among other things, this will understand HTML. And so we can construct it, with no arguments, or we can construct it with a URL as a string. And it has a method called setPage. And setPage will take a URL argument, and it will basically load the contents of that page into this editor pane. And that's really all we need to do here. So let's go back to our button code, and let's get rid of this. I'm just going to delete it. we'll keep this nice and slim. So this is very similar to code we wrote in yesterday's class, and that code I commented things out, and that code's posted on the website, so you can find that under, I think, Wednesday-URL or something like that. But we'll keep our code slim here. So we'll construct a URL object for that page, and then let's just say let's display this in our editor pane. So we'll say EditorPane.setPage, and the page we're going to have is just this URL object, so it's just page. And we don't need the scanner. Alright, so you've probably encountered this situation multiple times where I'm trying to do something with my editor pane and I'm getting an error saying that it can't be resolved, right? And the problem is simply that the way that Window Builder set up this code, my editor pane is declared down here, but my button listener is declared up here, and up here is where I need to use the editor pane, right? And you can start moving stuff around and getting all tangled up and so on, but the solution is really, really simple. Just take this, and instead of declaring it down here, just construct it here. Just say EditorPane equals, and put the declaration of it further up in your class. So I'm going to come up here. And I'm just going to declare my editor pane up here, but I'm not going to construct it yet. I'll leave the constructor where it is, because presumably Window Builder knew what it was doing when it decided to construct it down here. But now I should be able to access this. And now my question is, you know, am I going to throw an exception? So I have to put this inside a try-catch block. And I'm going to be a little lazy, and I'm just going to move this up into this block here. Alright, so we're up to 2 lines of code basically. Construct a URL object and then pass that as an argument to the set page. And, you know, obviously we could do this in a single line. We could just set page to new URL. But let's see what this does. Go ahead and hit the button, and magic, we've got a little web page. Now, it's not incredibly useful yet. I can click and it kind of goes, you know, somewhere else, but it's not really responding to mouse clicks. I can select my text, but you know, I can type in here. Well, that's kind of weird to be able to type in a web page, you know. And it's always tiny, right? Because it's got a fixed size. But you know, this is definite progress. All right, so let's keep going. So next thing to add would be scroll bars. And Window Builder again is going to make our life pretty easy for us. So let's add a JScrollPane. And all I got to do is in Window Builder, I'm going to click on this editor pane. I'm going to right click. I'm going to say surround with, and I'm going to choose JScrollPane. And now if I run my code and I hit the go button, it loads my page, but I've got scroll bars. And so I can scroll, you know, horizontally or vertically. So that's pretty good. And you know, Window Builder is doing stuff when we say surround with. It's writing a lot of code for us, right? So it created a scroll pane It added it to our main J panel. That's what this content pane add does. But then when it made the JEditorPane, it added that to the viewport of the scroll pane. So I mean, we can write this code ourselves, and if we didn't have Window Builder, we would do that. But you know, an IDE makes these things pretty easy to add event handlers, surround with components, and so on and so forth. All right, let's take care of one more thing. So this is looking good, but you know, there's this fact that it's a tiny little window, and it would be nice if the window got bigger when we made our whole J-frame bigger. And in fact, there are window managers that'll do that for you. I always start with an absolute layout manager in here, which means, you know, you place a component, that's where it sits. Whatever size you give it in the design window, that's the size of it. There are other layout managers you can use where you can say, hey, I want this window to grow according to the size of this window. And so you can choose from different types of layouts and dig into those and have this thing respond to changes in size. And normally if you're doing, you know, an application that's going to be used by other people, particularly something that might be used on a mobile device, on a tablet, on a laptop, on a 55-inch screen, you want something that can respond to different changes in the size of the display. And a layout manager will do that for you. But it's another thing to learn, and I don't want to spend time here learning about you know, MIG layout or spring layout and stuff like that. So let's do this by hand, right? Let's automatically resize this this scroll pane based on the size of the J-frame. And this is almost no code, so I'm going to select my J-frame, right? And if I select this, I'm on my content pane. I'm going to select my J-frame. That's my top level container. I'm going to right click and I'm going to add an event handler. And my event handler is going to be for component, and it's going to be component resized. So in here I have, you know, code that will be called when the window is sized. And let's just put a print statement in here. And if you look at the code for a J-frame, you'll see that it extends a class that defines these methods get width and get height, which give you the dimensions of the frame. So I'm just going to print those out inside here. And let's see what happens when we resize our window. Well, originally it says size equals 450 by 300, because that's where it got its original size. But if I make this thing wider, you can see that first dimension increases, and if I make it taller, that second dimension increases. And I can increase them both, and I can make it pretty small. Looks like 9 by 28 is probably the smallest I can get. All right.
I have to wonder if there's some kind of library you can get that will read an HTML file and set it up as an AWT component.
That's almost what's happening here. It's not setting up as a component, but this editor pane is getting us pretty close to that.
Say that again?
I think this editor pane is getting us pretty close to that. Although it's not, you know, setting up a new component. There may be a library to do that.
It's like at that point you can really just slapdash it together.
Yeah, yeah.
That would be awesome.
It would be. Alright, so what is our scroll pane? It's just called scroll pane. So let's do this. ScrollPane.set, and I'm going to set the size, and if we scroll through all of this, we should be able to find a set size option. Set size will take an integer width and height, or it can take a dimension, which is just, a placeholder. So I'll set size. And what width do I want? I want the width of the J-frame. And what height do I want? I want the height of the J-frame. And we can get rid of this print statement. So we're going to resize the scroll pane to match the J-frame. And now if I run this, as I change my window size, my scroll pane seems to adapt. So let's go ahead and load a page in there. Right, and this is doing something closer to what we want. It's a little bit off though. Right, I'm missing some stuff here at the end, and I've got a bit of a border over here, but this is going flush to the bottom and the right, and that's just a consequence of the fact that my editor pane is sitting right here. It's starting, a little bit down and a little bit over. But I'm written code to make the size of this the same as the size of the J-frame. Well, if I make this as big as the J-frame, it's going to go from here down to about here. And it's going to go outside of my viewing area. So I'm just going to tweak this a little bit, and instead of using the actual size of the J-frame, I'm going to just back it off a bit. So I just need to find where I wrote that code. I don't know where I wrote that code. So I'll just come back here, I'll right click, and I'll component resized. Alright, so let's go to get width minus 75, and let's do get height minus 75. And so now we've got a little bit of border there. Let's back the height off a little more. So this is the kind of thing a window manager takes care of for you, right? But if you don't have that, or you don't want that, right, you can do these things yourself, because it's just code, right? Alright, well, we can view our web page. That looks great. But obviously we can't click because, this is just text. And in fact, we can change this web page, and we can delete it, and all sorts of stuff like that. So let's take a 5-minute break, and we'll come back and we'll talk about how to deal with these hyperlinks, and then we'll add a few bells and whistles to this, and that will probably do us. So let's take a break, and let's come back at 14:09. All right, so we'll be back in a few minutes. All right, we're back. Yeah, we're back. All right, so let's deal with links. So we can go into our design window. We can right-click in here. We can add an event handler, and we can say hyperlink update. And this method should be called when we interact with a hyperlink. So let's put a print message in here. And we'll just say inside hyperlink listener. So I can run this, I can load our page, and if I go over a hyperlink, nothing happens. And so there's one thing you have to change, and it's in the documentation, but it's a little bit buried. This is an editor pane, right? Which means that you can change the contents of it. If you're allowed to change the contents, the hyperlinks are disabled. So come into your editor pane, and down here where it says editable, just uncheck that box so that it's false. And now if you run your code, load your page in, go over a hyperlink. Oh, I hit the wrong button. We want it to be enabled. We don't want it to be editable. Alright, run your code, load the page, go over a hyperlink. Now we get a message every time that we move over a hyperlink or we leave a hyperlink. Or if we're sitting on a hyperlink and we click, right, we get an event firing. All right, so let's get some information about the hyperlink event. So we get this hyperlink event. It's called arg0. It's an argument that's passed to the handler. And let's look at the doc on that. So a hyperlink event used to notify interested parties something has happened with respect to a hypertext link. And there's two methods here that we're interested in: get event type and get URL. Get event type is going to return an object of hyperlink event.event type. And that has three static fields: activated, entered, and exited. So let's look at those. So let's print out the get event type, and let's print out the URL. So load your page, go over, there's a event type entered, and it tells me what the URL is, and that's the archive pics. If I leave, it tells me event type equals exited, and if I click, it says event type equals activated. And so the picture itself is a clickable link, and it resolves to this, GIF image file. And there's the copyright link, and there's some person's name, and so on and so forth. So we've got all the information we need, right? We've got the parts and pieces that we can use to actually make a mini browser. Let me see. Oh, cool. So, Oracle documentation, you can actually render HTML with Swing. That's cool. All right, so what we want to do here is presumably, respond to mouse clicks. So that if you click on a link, you move to a new page. So, this is a one-liner. So if arg0 get event type equals And let me find the documentation. Hyperlink event dot event type dot activated. Alright, so if the event type is activated, then let's go ahead and load a new page. So URL new page equals arg0.getURL. And how do we load a page into our editor pane? It's just EditorPane.setPage. It's just that. And this has to go into try catch because the page might not be available. And that should get us to where we can follow links. So let's make our page big. Let's go to Discover the Cosmos. Wait for it. There's our archive. We can device halos. And we can look at this person's page. And so we've got, you know, the rudiments of a browser up now. Right? It's a little slow. And it's obviously not, you know, JavaScript savvy, and it doesn't understand all the things of modern web pages, but
CSS.
yeah. But it basically works. And it lets us pretend we're like in the 80s, you know. I'm just curious.
I wonder how you would go about implementing Java though, or JavaScript though. If you really wanted to, it seems like it'd be really hard.
So I'm guessing that there's some classes for that. If you wanted to do it yourself, you'd have to write an interpreter, which is, you know, fairly complex. But I'm guessing there's some classes, some packages we could download that would do that for us. And you know, it's a moving target because specifications keep changing. I'm just curious what Clark's website looks like. I don't think it will bring up too much. Yeah, so I think they probably render their whole page using some kind of content management system. So I pick on APOD because it's a pretty straightforward page. All right, so what else would we like to do with this? We can display a page. We can click on links to follow those hyperlinks. What would be the next thing we would add to a browser?
Control F maybe?
To find?
Yeah, like a find in the editable area maybe.
So that would be cool. So we could open up this page. We could do our scanner loop, and as we read each line, we could search it for a particular pattern. And again, we can think about this regular expression class. Oh, it broke my browser. Huh, okay. Too many of them. So you can define a pattern which takes a regular expression with all, you know, the usual stuff, including characters, excluding characters, the anchors for the beginning and the end, and so on and so forth. You can make a string containing all of that. That's called a pattern. And then you can take the pattern and compile it. And it gives you, you know, an object of type pattern. You can pass that to a matcher and give it a string and a pattern, and it will tell you if it matches and so on. And so we could add, you know, perhaps a fairly sophisticated search function that would let us look for, you know, not just strings but regular expressions describing patterns. So what about a history? What if we wanted to be able to see like all the pages that we've visited? I could add a history button. And how can we keep a history of the links that we've clicked on?
We get a little cache.
Yeah, we can make a little cache. What might be a good data structure for that?
A linked list of strings, maybe.
Linked list of strings sounds great. So let's make a linked list.
Now we're basically making our own cookies.
Yeah. So let's record a history of pages. And we could do strings. I'm actually going to do URLs, because if we have the URL object, we can get the string out of it. But if we have a URL, we can also feed that directly to our editor panel, our editor pane. And what we're going to do is we're going to add a back button. Once we've got a history, we'll add a back button so we can go back to previous pages. And I'll just keep these URL objects. So let's make a linked list of URLs, and we'll call it history. And let's construct this when we hit the go button. So down here, let's construct a history list. And we'll have to import this. All right. So here's what I'm gonna propose. Let's make a stack, and let's always keep the current page at the top of the stack. So here's our stack. Here's going to be our original APOD, NASA Gov. Here's our next page. Here's our next page. Up to our current page. And this is going to be the top of the stack. So when we click on a link, we're going to push the new page onto the top of the stack. And then we'll add a back button, which will basically pop off the top of the stack and go to whatever the page was below that. And if we're going to do this on a linked list, we know how to make stacks with linked lists, right? We can either insert at the beginning, you know, of the list and remove from the beginning, or we can insert and remove from the end. So let's just go with the beginning of the list, and let's save our URL history. So I've forgotten all about linked lists. So add first and remove first. We'll add and remove the first element, and I think get first will just get us the first element without removing it. Alright, so we've constructed our empty linked list. So let's save our current page on there. Our current page is called page. That's a URL object. So we'll say history.add first. That's all we need for that. Now when we click on a link, we're in our hyperlink listener. We're going to find out what the link is that was clicked on. That's going to give us a new page. And at the end of that, after we've set the new page, let's go ahead and add that to our linked list. And now let's just look at our history. So we'll write some code for our history button. You live and die by auto-completion. If you don't actually drink the Kool-Aid, it's a pain. And I haven't drank the Kool-Aid, so I fight it. Alright, so this is just our iteration over the elements of the linked list. Let's just print these out from first to last and make sure that we're actually saving our links in the linked list. So we'll load our page. We can say discover the cosmos. We can go to meteor shower, and we can follow this person's image page. That's a glorious page. And then let's hit the history button, and you can see this reverse chronological history of our pages, right? So you know, ending with the page we're currently on right now, starting with our original page, which was APOD. And if we follow a link to forum, then that'll show up at the top while our page is all the same. So we can save these pages in a linked list, so now we can add a back button without too much issue. So let's put a button up here. Let's call it back. So how do we go back one page? So let's get rid of our current page. We'll just do history.remove first. And remember, the way our stack is made, the page we're currently viewing is always at the top. So when we say remove first, we're getting rid of that. Now we want to take whatever the first thing is in our linked list. That should be the page we look at. And so how do we get the first page? Well, that's just history.getZero. That will give us the first page. And what do we want to do with it? We want to use that as the new page that we're looking at. So it's just EditorPane, point set page. it's got to go in a try-catch block. All right, that's our back button. Again, it's 2 lines of Java, right? Remove the page that we're currently looking at from the linked list / stack, and then take the current top of the stack, which we've defined to be, you know, the beginning of the linked list, and use that to load the current page in the editor pane. And that should be plenty for a fairly full-featured browser. So discover the cosmos. Let's look at the Lagoon Nebula. Let's look at Sagittarius. Ooh, Stardate, awesome. And so now if we hit the back button, we go back to the nebula. If we hit the back button again, we go back to our picture index. And if we go back once more, we're back to our original home page. And you know, if I hit the back button again, I'm going to throw an exception. Why? Because I wrote my code really sloppily. And there's an index out of bounds exception, index 0. And that's happening right here at line 129. I'm trying to get element 0 of an empty linked list. So, you know, so what do? If history size equals 0, just return. No history left. Or, you know, you could gray out the back button at that point. When you've gone to the last page, you could make that button disabled, and you could re-enable it when you follow a link. Whatever you want. The punchline here is, right, this is just code. Right? Everything that we've done here, which has basically given us the ability to, you know, look at a web page, follow links, go back to previous links, and so on. We didn't really have to worry about any of the details of you know, how to talk to a web server. We didn't have to worry about issuing GET commands to request a page. We didn't have to interpret HTTP, HTML tags. We didn't have to do anything with sockets and server sockets and port numbers and all of that stuff. All of that stuff was encapsulated inside these objects. So we made an object from the class URL, and inside that object was all of the machinery we needed to do all of these things. Right? And this is the idea of object-oriented programming. If we did this in C, maybe we could find some libraries and we could call functions and pass information to them and so on and so forth. But we really don't care about that. Right? When I want to access a web page, I don't care about sockets. I don't care about servers. I don't care about port numbers. I don't care about tags like, you know, angle bracket HTML. I care about, you know, I want to access a page from this address. And if you click on a link, I want to get the URL of the link you clicked on and load that page. And it lets you focus on those particular parameters. We wanted a back button, we wanted a history, we needed a linked list. We didn't have to worry about sentinel nodes and mallocs and following links until we get to null and all of that stuff, right? That's encapsulated inside the linked list class. And the only thing we had to do with linked list was construct an empty linked list, and then say add a page to it, or say remove a page from it. Right? This is why we do object-oriented programming, because it lets us take all of these building blocks and you know, they're nicely containerized, right, encapsulated in these classes. And we can use them to build, you know, whatever it is that we're actually trying to build, and we don't have to get mired in the low-level details. And so this is I think a pretty nice example of probably 10 lines of code that we've written that let us do something like this. And, you know, you could put a text field up here and put a little place where you can type, and when you hit the go button, instead of loading apod nasa gov, we could say, textfield.getText and use that as the argument. In fact, let's do that because I'm kind of curious if we can hit other pages. Let's just make one more embellishment on here.
Quick question while you're doing that.
Yeah.
For like the forward button, would you just use another linked list and just kind of move from one stack to the other, basically?
I think for the forward button, if I wanted to be able to go back to links I've already gone back from, instead of removing from the linked list, I would just move an index, right? So keep adding pages to the linked list, but just say, okay, we're going to go to, entry 7654, and then if you go forward, just add one to that.
Okay.
That would be
Okay,
cool.
Yeah, that's smarter.
So let's make a text
Also less
field.
memory intensive, I guess.
Yeah, we don't care about memory though. We're Java programmers. So let's make a text field called where, and let's change this go button. Instead of going to apod nasa gov, let's go to where.getText. And we'll be nice and initialize this. We'll initialize it to something usable. So if I do that, it should load the page. So what if I do I don't know if this will work or not. Hey, there we go. So there's my bogus web page. And I don't know what it's doing there. Let's try our shared code area. Hey, there's our shared code area. So we can go down to 223 and we can look at, I don't know, let's look at our socket code from last Thursday. All right. So we've got, a thing going. This is not going to work. It's going to take me to YouTube, and YouTube is not going to render nicely in this, as you might expect. All right. Yeah. I mean, there's probably, there's the word YouTube in there, so it kind of worked. But hey, we got a back button, so that's all good. And we can see our glorious list of topics. That's nice and organized. All right, so there you go. So like I say, the punchline here is really, I mean, URL is a cool class and EditorPanes are cool and so on. The punchline here is really this idea of encapsulation, this idea of object-oriented programming, and being able to take the code that manipulates an object and bundle it with the data itself. And this is where stuff gets really, really fun, because there's so many classes out there, and if you want to, do computer vision, There's classes, for OpenCV that will do things like object detection and edge detection and filtering and noise elimination and so on, and you just use those, and you say, hey, I want to know, when somebody holds their hand up like this, and when they do that in front of the camera, I want to pause my music, and it lets you concentrate on the fun stuff. All right, so any questions or other comments and such on any of that? So somebody asked, yeah, go ahead.
No, I was just gonna say it was really cool.
Oh, cool, awesome. So somebody asked yesterday about source code for some of this stuff, and I'd almost forgotten to talk about that. So let's just take a look at.
Do you think maybe it would be possible to talk about decompilation a little bit?
Decompilation?
Yeah.
Huh. Have you tried?
Uh,
You're talking about bytecode in particular?
well, specifically for this language, because in when I use Visual Studio Code, it has like an auto decompile on classes. So
Mm-hmm.
if let's say I was working with a linked list class and I click on the class type and hit F12, it will decompile the actual
Nice.
class behind it, and then I can see what it's all about. But I was wondering if maybe there's just like maybe a standard way to do it from the terminal.
So I don't have any tools downloaded for that. I'm sure such tools exist. So the idea is, you write Java code, you compile it with Java-C, you get .class files coming out, and our class files. Are mostly binary. They have some, human readable stuff inside, but it's mostly compiled code. It's called bytecode. Theoretically, you can take that bytecode and, to some degree of success, turn it back into source code. With varying interpretations of that. So in general, comments get removed when you compile code, so you can't get comments back. In general, some of your variable names might get removed. Obviously, formatting, things like that go away. But it's a many-to-one mapping, right? Lots of different source files will produce identical binary code. And so a decompiler is a way to sort of start from the binary and try to get back to source code. And typically, do some kind of formatting and possibly add some auto-generated comments. I haven't played around with decompilers for Java bytecode. I'm sure you can find them online, and they probably work reasonably well in most cases. And it will help you appreciate good commenting, by the way, if you start working with decompiled code. But in general, well, let's just find some C code. I'm making this up. So, GDB is a way to, one way to do actually disassembly. So with compiled languages like C, Fortran, etc., where you're actually compiling into the underlying architecture, we can do something like layout ASM and look at assembly language code. Now the ones and zeros, right, are accessible because that's what's stored in the memory of the machine. But most people don't read ones and zeros. But translating from the ones and zeros into assembly language is closer to a one-to-one operation. Labels get lost for the most part, except I use the -G switch. So like the label main has a fixed address value, and so that can get used. But calls to functions and so on and so forth generally get lost. But disassembly is sort of a precursor to decompilation, and disassembly is more straightforward. And so I would guess there's also bytecode disassemblers. I looked at bytecode years ago when I first started playing with Java. I believe it's a stack-based architecture, so top of stack operations, but haven't dug into it in a long time. If you've done Engineering 270, you know about disassembly, right? Because you can get a disassembly listing in one of your windows of MPLab and see something like that layout. But it's an interesting question in general.
I played around with them a little bit in Visual Studio and some other tools.
Mm-hmm.
It's always a window that's there, and then you can even put breakpoints in it and stuff around.
Cool. Well, sort of along those lines, Java is open source, right? So the source code is freely available. You can download it. You can do what you want with it. More or less, there's different stakeholders in Java, but I've downloaded the source code and we can look at this now. I didn't download all of the source code, but for example, if we go under math, there's source code for big integer, big decimal, math context, and so on and so forth. So big integer.java is the class big integer. So it's free software. It's under GPL version 2. And so you can kind of do what you want with it, as long as you keep this copyright notice on it. So this is the Java code that implements a big integer. Well, let's do one that we're more familiar with. Let's do a linked list, right? So this is the linked list class, and it imports something called a consumer. So that's another class that this class uses. So it's got a copyright in the beginning, right? Ownership by Oracle, and so on and so forth. And then it's got a bunch of comments in the beginning that describe the class itself, right? So this is the comment block I've been asking you to put in the front of your code, and it's tagged with this /*, which means that if you run this file through JavaDoc, you'll get an HTML page out that contains a nice formatted version of all of this information. And if you look at the linked list page, W linked list implementation of the list and DQ interfaces, that's this comment right here. Right, so all these reference pages we've been using all quarter, these are generated from the actual source code for these classes. So there's the declaration of the class. It's abstract, as we know. It implements some interfaces. It's got something called size, which I believe is the size of the linked list. And the usual constructor, which doesn't do anything, right? Takes no arguments, does nothing, except the stuff that a default constructor does. But let's find the add first method. So add first takes an argument of type E, that's the parameter on the linked list, and all it does is call link first. So it's just a wrapper. So what does link first do? Well, it does some stuff, right? This looks like a little bit like our linked list code from 222. So we construct a new node. We set first equal to that new node. If f is null, which was the old value of first, then we set last equal to that new node. We can set f previous to be our new node, so the thing that was in the beginning of the list is now pointing back to our new node. So it appears that this is a doubly linked list. It also appears that there's a variable size that gets incremented every time we add something to the list. And there's a modification count which also gets incremented when we add something to the beginning of the list. If we find remove first, well, that calls unlink first. And unlink first, same thing. It's removing the first thing. It decrements the size, but it also increases mod count. So unknown to the users of this class, I mean, it's not a secret, but you know, not in our face is the fact that every time we modify the linked list, apparently there's a count that's incremented to keep track of how many changes have been made. What is that used for? I don't know. I'm sure it's in the documentation somewhere, and we could look through the code, and maybe this is used to, you know, do some kind of memory management, or maybe there's something we can access to read that information. Here's the size method, and as you can see, all that the size method does is return size. So it does not begin at the first node and move till it gets to the end and keep track of how many nodes are in there. That's inefficient. Instead, we have this variable size, and we just keep it updated with the current size of the linked list. And so this is a really good example of information hiding, right? The reason that we have information hiding is because a clever programmer might decide, hey, I just want to add something to the beginning of the list. I'm just going to take, you know, the sentinel node and have it point to my new node and have that point to where the sentinel pointed. And if they did that and they did not adjust the value of this variable size, our size method would be broken. So by using information hiding, this implementation of a linked list prevents somebody outside from coming in and tinkering with the list except through these methods. And these methods, when they modify the list, will do the correct thing with the size variable, so that this method always returns the actual correct size of the linked list. But if you didn't have that ability to restrict or control access to the different fields and properties inside an object of linked list, somebody could come in and manipulate the list in a way that did not, you know, follow this protocol of let's always keep size updated to tell us how many things are in the list. And so this is the other aspect of objects, right? We've got encapsulation, where we take all these capabilities and we put them together into an object, and we've got information hiding, where we make sure that things outside the class only interact with things inside the class in a very carefully controlled way. And so that's what all this business of public and private and protected is about. And so linked list is a 1200 line class, right? It's all written in Java, which is cool. You always like languages that are written in themselves. And so if you know Java, you know how the linked list works. And, you know, I could make an extension of this and modify changes, or, you know, I could just take all of this code and put it into a nicklist.java file and change the name of the class to nicklist, and now I could tweak this. And, you know, if I didn't like something about this and I wanted it to do something differently, I can come up with my own version of this. So scanner.java, that's 2,600 lines. This is a more complex task, and among other things, you know, it uses the regular expression package and locale information so that it understands, you know, characters that are specific to one region or another. And this is all documentation, right? All of this stuff in the beginning, this is a comment. This is the comment block in the beginning of the class that tells you all about the class. So if this said, you know, a class for scanning, well, that wouldn't be terribly useful, right? So it's got all this information in here. And then the actual declaration of the class. It's declared final, so you can't actually extend this. But, you know, you can always take the code and put it into your Nick scanner class and do what you want to that. And this does a lot of the stuff that students sometimes try to do before they know how to use a scanner. Like saying, okay, well, I'm looking for a number. Let's look for digits, right? Or if it's a hex number, let's look for digits plus the letters A through F. And let's allow a minus sign in front, but not two minus signs, right? That's part of what goes on in here, because scanners have things like, you know, next int, next double, next float. And those will not only ingest information from the scanner, but will do parsing. And we'll say, hey, starting at the current point in the scanner, if I look forward, does that set of characters I see constitute an integer, a double, a float, a Boolean, and so on? And so this is a lot of powerhouse code in here. But it's all just Java, right? I mean, there's very little in here that is different from the code you've been writing, you know, for the past 9 weeks. In this course. It's just Java. And a lot of languages are written in themselves, which is something to contemplate late at night. But, you know, C compilers are written in C. And so how do you get an executable? Yeah. And
It's like, wow.
yeah. But I mean, once you have one C compiler, you can write more C compilers in C and just compile them with that first one, and then, you know, you can make a better C compiler and get a better compiled version and so on. Kickstarting it is tricky, but, you know, at some point, you end up with an IMSI 8080.
Some of the early C++ compilers, Yarnist Rustrup said he kind of hijacked quite a lot of the C compilers.
Oh yeah, yeah. So this was one of the machines I cut my teeth on when I was an undergrad. It's an IMSI 8080, and to program it, you just flipped these switches in the front, and these switches represented a 16-bit address, and you would flip them up and down to load ones and zeros. And when you got to the address that you wanted, you'd flip a button and that would lock in that address. And then you could flip these 8 switches to represent the 8 bits you wanted stored at that address. And you could flip a store button and it would store those 8 bits at that address. And it was fancy. It had a store and increment so that after you stored it would increment that internal address. So you would just have to flip in the 8 bits for each byte of instruction that you wanted. And after you toggle in each 8-bit pattern, you hit the load and increment switch, and you could see what address you were at on these lights, and you could load in, you know, the contents of the memory through the front panel. And a bare bones IMSI 8080, that was the only way to program it. And so the first thing that you do is you program a bootloader. And you have something like, you know, a paper tape reader or something that that you can more easily type, you know, characters onto, and you toggle in a bootloader that will load in a more powerful bootloader from paper tape, and that bootloader might do something like read in assembly language and translate it into ones and zeros. And so this is what bootstrapping is, right? It's starting from something at this level and building up to higher and higher steps. And so when you boot a machine, you're beginning with the bare bones bootloader, which is sitting at a particular location on your hard drive usually, and contains just the information needed to be able to start reading in a larger program from elsewhere on the disk. And that program sets up, the low-level I/O routines and so on, and lets you write a big enough program to load in, the start of your operating system. And then from there, you can go ahead and boot up, Linux or Windows or whatever. And so these things happen every time that you boot your machine. These things happen, back in history when people were first developing computers and coming up with assembly languages instead of machine language, and then moving towards compilers and high-level languages. And it's one of these things, if you went back 100 years and tried to tell people about this, they'd probably lock you up, because it just sounds so insane. And the fact that you can download, a 2 gigabyte game from the web and it does stuff is just pretty crazy. So source code for Java is fun to look at, and if you downloaded all of it, it would be pretty big, but not horrible. So I think that's 52 meg, so that's not too bad. But that's pretty compressed because it's a zip file. But there's, the whole source code for everything we've been doing. All right. Any other questions, comments, thoughts, final PA5 discussions? So I'll let you out 7 minutes early today because it's Thursday and it's sunny and it's warm out, and we're at a good stopping point. So Tuesday, I'm not sure what we're gonna do. I might talk about Android development and go through that as kind of a parallel to what we've been doing with Eclipse and Java. I might talk about C++ as a different object-oriented language. We'll figure out something interesting to do on Tuesday. And then Thursday, we'll concentrate on talking about the final, doing some review, go over a list of topics, things like that, and then we're done. Final exam the following week, and you're out of here. So we're pretty much at the wrap-up stage after this. All right. I'll grab my chat window and see if I missed anything. Yeah, that is related to an Altair 8800. Same idea.
Pretty cool.
Yeah, and if you're interested, so I actually last summer went a little crazy and made my own version of that. So this is an IMSI knockoff, and it's got the annoying little switches in the front that you can like flip up and down, and all the obligatory LEDs that turn on, and the same things, right? The load and run buttons and reset and so on and so forth. But
You
it's
should like make a giant switchboard for it.
yeah, totally. I actually started to make a panel that I could plug in, and I got hung up on the 3D printing of the switch paddles themselves. But I got the whole bus exposed over here, so I actually booted up CPM on this at one point, and it's got a wireless interface, and it's got gizmos that the old IMSI did not, so you can actually talk to it in assembly language, and it's got a built-in debugger and all kinds of good stuff like that. And there's a Hackaday page you can search for and find that gives you some details on it. But anyway, yeah, so fun stuff trying to start from, like, the ground and build your way up. And someday I want to do a course built around these things, and get people to work from, the level of toggling in code with switches up to, booting something like CPM, where you have like a full-blown operating system with a hard disk. I think that would be a fun, like, summer course or something. So it's on my long-term wish list. Anyway, I'll let you out of here early. Have a great afternoon, great day. I've got office hours tomorrow morning at 7:30 as usual. If you've got any last issues, come by then. Otherwise, I will see everybody Tuesday for class, and then right after class on Tuesday, we'll go ahead to SLP presentations. So we'll end class like 10 minutes early for that.
Have a great weekend.
All right, thanks. You too.
Nick.
Take care, everyone.
Good one.
All right, bye.